And one thing I want to do is, to start off, is right here creating a new rectangle. What I want to do is actually, I'm just going to create a quick function here, which is in our rectangle, we're just going to public function clone. And so this will just clear this up for us real quick. So what we're going to do is, we're going to test for it real quick. I'm going to say should clone a rectangle, clone itself. Alright, nudge. And so we're going to say rect2 rectangle equals rectangle clone, and what we need to do is we need to return new rectangle. Oops, rectangle. So that'll not crash but still fail. Assert art equal rect2 or rectangle.x rect2.x and y width height, that over here, y width height, test that, and then we can easily do x, y width height, and that'll get us working again, passing at least. Amazing to me what needs to build in order to make this happen. Seems like there could be some optimizations there. So there's our fail. And we're going to get back into our quad tree. There we go. And so we're back into working order. And now we can just say new rectangle. Oh, that's the test. Quad tree node. We're just going to say quad tree node. It's going to just be here. Area clone. So that'll make that simpler. Here's our quad tree. It's looking fine. There we go. And now what we want to do is, instead of doing total width and height, we also need to do an offset. So here we're just going to say rectangle. And that's something we need to change here. So now, where's our quad tree test? And we create our new quad tree. We call it our total area rectangle, and I think we'll do the same thing as the same variable name, so I like that better. Call this total area. And let me notice, I think our coverage on quad tree is complete. Our quad tree node. Are we collections, quad tree node? Yeah, it's 100%. So that's fine. And here, total area equals new rectangle. I would do 50, 80, 800, 600. Total area. And so that should get us our failure case that we want. Probably not. Apparently not. It's not really doing anything with it yet. So I'm just going to store it for now. Total area. Rectangle. And same thing here. we're going to do this total area equals total area clone, so we don't have our total area messed out from underneath us. Now, we have our add, and what we need to do is that we need to start doing some more testing. So one thing we added yesterday, start clearing some of this out, is we have getRect for data, and we're going to need to get the rectangle for the data. I think we have that. It's in the quadtree node. So what we could do is say test should get data for, get rectangle for data. So what we're going to do is effectively this, and we get items at point. Yeah, and now we have our data. So for item data, which is dynamic, items 0, and now we can say item rect equals quadtree get rect for data item data. Assert are equal 200 the item rect x y width 8, and this will be 100 20 20. So that should fail, and indeed. Now, the problem is that we have the data. This is kind of an expensive operation as well. So this is also very expensive. So now we're just going to do for go away. Okay, so for item in index, if item dot data equals data, return item dot area. So that'll pass, and now we can do test should return null if no rectangle for data. So it's this. It's kind of a weird case. Actually, not that weird, because we just do this. And pass it nothing. Assert is null. Item correct. There we go. All right, so let's take a look. I want to see, make sure we're keeping really high test quality here. We still have our quadtree test. We're missing stuff, which is probably this. So I'm going to say test should get all data from tree. So we're going to do this, our items array dynamic equals quad tree get all data, and we'll just say assert are equal 1 and items length. So what we're going to do, we're going to make this slightly better. So for I am 0 through 50, we're going to insert some data, and we're just going to print it. Oops. So, and now we should have 50 items. Goal. So that one failed, and what we're going to need to do is we're going to need to for var rectval array dynamic. So these are return everything, and for item in index rectval push item. Oops, data. And we need to, what we'll do is I'm going to grab an item dynamic equals equals items 0, assert are equal could insert the same data every time. I didn't really test anything. Value equals I. Say 1 or 0 item value. And so that'll at least give us a clear representation. So turn to null, so this is where it's going to be fixed. And success. Alright, so if you look at our quad tree test, we're still at 94, so I don't know what we're missing. That's one bummer thing, is that it's hard to know what we're missing in this deal. Probably something related to get items at point. So here, I think you see a test that we want, which is here. That's not the one. Make this a node. So we're going to say get item should return null if nothing found at point. Okay, and we're just going to stick a point 0. So that passes, and just our, yep, we're fully 100% now. Oops, this one here. Okay, so looking good. So now, as things get more complicated, it'll be easier to maintain that. So what we need to do is we need to say remove, we'll say public function remove, and remove it by data, area, rectangle, data, dynamic, and we'll return that. So now, test should remove item. Okay, so what we're going to do, problem is that can't use area, so it's going to be inefficient. Which is kind of a bummer. Okay, so now I'm going to add this one. Should do is item to remove. This will be a dynamic. And we'll just say if I is equal to 18, item to remove data. Okay, so it's kind of a weird spot, but that's kind of the idea. So we're going to say var val dynamic equals quad tree remove item to remove, and we'll say assert not null. That's not null right now. And assert our equal item to remove is equal to red val. So now what we're going to do is we're going to say get looks like we're just going to have to do something like this here. I'm going to have to get to all of them. Right. Val dynamic equals null, and if item is equal to data instead of calling this a index, I'm going to say this is called the tree. It's better. Okay, so we're going to return item.data. Okay, test should return null if no item found on remove item. And then this is going to be here. I'm going to remove the same item again. And I'm going to search that it is null. So here, it looks like we got an issue. Okay. Item dot data. Item data dynamic data. And killing a ton of birds with one stone on this one. Ton of stones with one bird. Okay, we still have a failure, which is should return null if item not found on remove item. Oh, so one thing we didn't do is we didn't remove it from the collection. So I'm going to say tree remove item. Cool. Awesome. All right. So now we still have very good test coverage here. So what we need to do is we say test should remove item at point. And so now it's basically this. Okay, and then we need to quad tree remove item. It could overlap. We don't actually know that. So it's kind of an interesting dilemma we're in, is that if they overlap, so we could do at point, we would send in a point, which is new point, and it's going to be like 215. Yeah, okay, that's in there. What do we do for if it's not found? Okay, so it's way out. Okay, so if we remove item at point, pass in a point, 220 and 10, and we're going to pass the data. Okay, so we're actually going to remove 1. Public function remove item point data dynamic. And this is going to return dynamic, returns the data. Var data item data is equal to that. And now assert our equal. Actually, what we're going to do is we're going to say item to remove. Do that. Item to remove is going to be just say rect to remove. Rect to remove equals rectangle clone, so that we know that it's not the same one. Item to, don't need this at all because we're just putting these in here. And this is going to work out very well. So now, item to remove, and what we're going to do is item to remove, item data. Don't think we need this. Take this out. Okay, items at point. No item at point, so return this so that doesn't crash. And actually this won't work because there's no way to know. Oh wait, yeah. So yeah, we can actually match it against the item. Okay, so yeah, we're still good here. Oh. So I'm going to do, okay, so it gives us our failure, and now we're going to effectively do this, but I think instead of just calling this function, which is dry, I want something more efficient. So what we're going to do is effectively copy it, and we're going to want to know actually we can do this, make that more efficient. You know what? Now we're going to have to go through that. We're going to have to go through the list 1.5 times. So yeah, we can call it. So, no, we can't do that. So we're going to do var items at point array dynamic equals items at point. That'll give us all the items at that point for items, and items at point. And if the item.data is equal to data, return the data, but we're going to need to do tree.remove item. So one thing we need to do is this again, and assert is null item data. So at that point, we tried to remove it twice, and it shouldn't be able to do that. So here on 137, item data, item to remove, that value, that value. And it appears that it's not being found. So, let's see here. Should get quite a few here. Assert is true. Item set length is greater than is equal to. See here, the point is at 220, so we should get about 20 here. And not equal. That's a bit more data here. So let's see here. It's giving us 21, which is quite probable. So I'm just going to stick with that. So here we're getting a null value. We're going through, we get all the items at the point. So we're just going to trace items at point length. That should be 21. And it is. And then item to remove data. In fact, these should be the exact same items. And they're not. Probably because it's not found. So we're going to get into some leaf nodes and stuff like that soon enough. So this one still wasn't found. So let's figure out what's going on here. IN items trace I touch trace I. I expected that one to show up. It's 20H220, yeah. And so at point, that's not what I expected to see. So we're going to go through this and grab all the ones at point 220. So many of these, trace, rectangle, X, just make sure we're looking at the same thing here. So it does start at 200. At this point, it should start collecting them. And they're not. It should be 18 through something. So we have a bug. So what we're going to do, we're going to isolate this down. To be able to find out fishing item at rect. Actually, this should do string interpolation here. At rect.x rect.y. Wow. Here we go. So now, so I didn't do the string interpolation, and I don't actually remember the syntax, so x string interpolation. Oh, $sign. Okay. That's easy enough. Oops. That's it? Okay. Rect.x, comma, rect.y. Okay. So, okay, here we are. Push an item at that. So that is actually kind of weird. Because our rectangle, our point is at 220, 110. So this actually definitely fits, but our point should not be true. Why is that true? Rectangle. So rectangle test contains point. So 50, 50, so that makes sense. So let's write a test here. Test should contain point. And we're just going to set the same data. So we're going to have a rectangle at 220 or 205 rectangle, and we're going to have a point. Assert is false. And so I'm going to do our point, which is 221.10, 220 and 10. New point. Rectangle contains point. So this should be false. According to our other test. Huh. So that one succeeds. Oh, wait. What's it say? Oh, there it is. So this is wrong. Contains point 220. Is that correct? 205 and 20. That would contain a point, right? That would be true. That would be true. So let's check that out. We have to think about the width and height here. So this would actually contain point. So if we do 18, at 18, okay. So those are the things that contain that. Do 20. The downside is, so here's all the items. 18 should be on there. There's 218, 100. 18's on there. There's that there, but it's still not being found. So we're out of time for today. I'm going to have to debug this tomorrow. Boo. Alright. Sorry, everyone. Till tomorrow, happy coding. See you then.